Hello everyone and welcome to my channel, and today we are going to program finishing toolpaths on this tutorial. This is the second part. In the first part we roughed the 3D model complete, including those internal features. Oh, and there's one thing: when I was creating the stock model for this tutorial, I realized that I didn't add this pocket to my collision control, and in the result we were overcutting depth of this pocket. Okay, so if you want to fix it, just go to trim collisions, check surfaces, select surface and double click on the wall of that pocket. Okay, so as I mentioned, I created stock model, and this is how this part looks like after roughing. And we can have a look how much material we have left, and all this blue area, this blue layer around the part is my stock that's left after roughing. Okay, with our first toolpath of this tutorial, we are going to finish the areas between blades, this external diameter here, and outside of those arms, 4 arms, plus this diameter, small diameter here. Okay, so for this I'm going to use a long curve. So I'm going to activate the rotary level, and we had save this center line that covers the whole length of the part. It is between this face center and this face center. Okay, so I'm going to use it as our lead for next toolpath. So let's go to Toolpaths tab, and in the multi-axis gallery I'm going to use a long curve. I'm going to use a formable nose for finishing toolpath. I want to machine all faces, all surfaces that I'm going to select. So I'm not going to use stock. I want everything that I select to be machined. In the cut pattern page, my lead, I'm going to select this center line. But this lead doesn't have to be in the center. I can draw a line somewhere here, as long as the length of the line covers the whole 3D model. Mastercam will generate the passes that are 90 degrees to the lead. I'm going to present that later. So my drive surfaces, I want to machine the floor of this area here, those arms, this diameter, and those 2 arms here. So this is what we have at the moment selected. And I'm going to leave those settings as default. For the surface quality, you can tighten up a little bit the tolerance if you want better finish. Activate maximum distance underneath the cut tolerance and set it to roughly 0.1 millimeter. And of course, step over. Use tight step over to get better result, better finish. Probably for finishing toolpath like this, about 0.05, 0.07 millimeter. And the cutting method, I'm going to use zigzag. The reason is because I want to cut the part across, and when we going to start hitting these areas between blades, I want the toolpath to actually, without retracting, go back and forth the zigzag direction. Okay, because if we're gonna select one way or spiral, it will result with a lot of retractions that I don't want. And machine by, I'm going to select regions. So again, if we start hitting those areas between blades, it will go around, and then without retracting, it will go as far as possible without retracting the tool. And then when we finish here, it will move to the next area. My step over, I'm going to leave, for this example at the moment, I'm going to leave as 1 mil. But as I said, I will use something much tighter or much smaller as a step over. And the cut pattern, also here I'm going to add a slow and safe path creation. Those settings I'm going to use as default, leave as default. And tool axis control, I'm going to use output as 5 axis and leave tool axis control as a surface with tilt. And also I'm going to leave ortho to cut direction at each position, the side tilt definition. And if you want, you can add a little bit of side tilt to avoid cutting using the tip of the ball nose. Okay, so you can tilt a little bit. I'm going to leave those as 0 and 0. I'm going to leave those as default. And the collision control, I'm going to set 2 levels of my collision control. And if any part of the tool would hit my blades, I want those collisions to be trimmed out. Okay, so I want to use that, okay, only blades as my check surfaces. Okay, so these are my check surfaces, all the blades around. And I'm not gonna leave drives, just checks. And here I want to retract the tool along tool axis if we hit any of my drive surfaces. Okay, I'm going to leave those settings as default and going forward to linking. For small gaps, I want blend spline, and for large gaps, I want to retract to clearance area. And my clearance area is going to be cylinder on the Z axis, and I want to use radius 60. Let's have a look how our toolpath looks like. And this is our toolpath. So as I mentioned, this is our lead, this line, and our cuts are 90 degrees to the lead. Okay, so our line is vertical, our cuts are horizontal. And as I mentioned, the line doesn't have to be in the center. And if you select something that is shorter, it will cover only this area of 3D model. And I'm going to show you that. Oh, where did it go? Here. Okay, so let's reselect our lead. Let's regen the toolpath. And this is the result. As I mentioned, we don't need our lead to be inside the 3D model or on the surface of the 3D model. It can be a way Mastercam will generate passes on the 3D model that are 90 degrees to the lead. Okay, so I'm going to change my lead back to what I had, and for our example, I'm going to use 0.3. As I mentioned, I would use something around 0.05. Okay, this is our toolpath. I'm going to remove this line. So this is our part and 5-axis machine, and this is how it would get cut. So this is horizontal face, so there is no A-axis. But when we start cutting those arms, A-axis will tilt to keep the tool normal to the surface. This is it. And now we are back to A90. So this is how it looks after machining this first toolpath. Before finishing those blades, I'm going to quickly set up pre-finishing operation, and for that I'm going to use Rotary Advanced, and I want to use 3mm ball nose. Stock model, I'm going to use the initial stock for this tutorial, so the most recent, the stock model 4. In the cut pattern, operation machine, I want to select finishing, and I'm going to leave the method as zigzag, but you can go one way if you want. And I'm going to change the depth step to be 0.3mm. I'm going to leave additional cuts and adaptive depth step. Part definition, I want to leave 0.1 for my finishing toolpath, and here I'm going to triple click on the 3D model to select the whole 3D model, and I'm leaving 0.1 stock. So I'm going to tie up a little bit my cut tolerance, and as axis of rotation I'm not going to select anything at the moment. As a standard, Mastercam uses Z axis, okay, as a rotary axis. So I'm going to leave without anything here this time, just to show you that it will generate the toolpath correct. And machine area, you can only have this, but I'm going to set some limits. I don't want my toolpath to go deeper than right click, radius on an arc, and I'm going to select this arc. So I don't want my toolpath to go deeper than 43.5mm. Linking parameters, I'm going to change approach move to line at 90 degree. I'm going to leave standard settings here. Clearance is okay, and just let's double check the planes. I want top, and I'll activate coolant. This should be all. Let's see the result, and I'm going to pause the video. I don't want you to wait in front of your screen. That wasn't that long actually, and this is the result I wanted. So we have pre-finished blades. To finish those blades, I'm going to use triangular mesh as my tool. I'm going to use 2mm ball nose. Cut pattern, I want to use geodesic. I want to use type as offset, and my machining surfaces, so I want to cut this blade. Okay, so double click on the blade to select the one blade. And I want to tell Mastercam what pattern I want to offset. So I'm going to place the tick in the box here next to output pattern, and I'm going to select my drive curve. I want to be on the solid selection and on the edges, and I'm going to go around this edge. No, I want to go this way. Okay, so this is my selection. Okay, and my step over, I want to go 0.1 or 0.15. The cutting method, I'm going to use a spiral, and that should be all. Okay, so I'm going to leave to close first and last contour. I'm going to arc fit. That's okay. That's okay. Tool axis control. I'm going to change the output format to 4 axes. I don't need 5 axes for this operation. And direction is Z axis of my 4th axis. If you want, you can point the tool to rotary axis, to the center of the axis. I'm going to leave that unticked, so the tool will be able to tilt a little bit only on the rotary axis. This is okay. Collision control. I'm going to retract the tool, use flute and maybe shoulder, and I'm going to add check surfaces. And my check is going to be that. That's okay. Linking. I'm going to go by direct and retract to rapid distance, and as a value I'm going to use 5 mil, even not 3 mil. So clearance area I'm going to set as cylinder on the Z axis and 60 millimeter. I'm not going to use anything in roughing. In utility, later on we will come back and we will set the transform translate operation. This is top, as most of my multi-axis toolpaths. And let's use current. Okay, and this is our toolpath. Looks okay, is what I was looking for. Now we can use the transform inside the toolpath to finish the rest of the blades. And we have 6 blades equally spaced around this drum section. So I'm going to go to utility, transform, number of blades is 6, and they are equally spaced, so it's 60 degree. And this is our toolpath for all the blades. All looks good. Okay, so with our next toolpath, I'm going to finish walls of this cutout on top of this 3D model. And for that, I'm going to use simple swerve toolpath, and not swerve milling, just the swerve in application section. I'm going to use 4 mil ball nose and mill. I'm not going to use stock cut pattern. So what you want to cut? I want to be on surface and double click on the face to select all the walls of this cutout. Now Mastercam asks us which one is the first face we want to cut. So I want to cut this face first. So now which one is our lower edge, lower rail? So drag this arrow to the bottom of this face, and now Mastercam wants to know what direction I want to go, and this is the correct direction because I want my cutter to be on the left hand side. And I'm going to go one way, and the compensation I leave Mastercam to do on the computer. Direction of the compensation, I want to be on the left, and And tip compensation, I'm going to leave as tip. I don't want to leave any material on my walls because that's finishing toolpath. And this is all what I want. I want to enter it at the middle of the first wall that we just selected. And in the tool axis control, I want my output format to be 5 axis. And the rotary is on the Z axis, along the Z axis. I'm gonna minimize the corners in toolpaths, and the rest of the settings I'm going to leave as default. Okay, let's move on to collision control, and as a tip control I'm going to select a plane, and this is our final cutting depth. Okay, and I'm going to select a plane to go below bottom rail, okay, of our faces that we are cutting. And I'm going to use Z offset, and I want to go at least to the bottom rail, but I'm using a ball nose to cut those faces, so I need to add half of the diameter to the depth. And also I want to pass a little bit. I don't want to be exact on the bottom edge. So I'm going to add, let's say 0.5 millimeter. I'm going to go -10. Okay, so this is my final depth. So we'll go around and the cutter will be on that plane that we selected, the final depth. Okay, and I'm not going to use any compensation surfaces or check surfaces, and rest of the settings on this page I'm going to leave as default. I don't want my tool to oscillate during the cut. I want one smooth cut on the same depth. In linking parameters, I'm going to leave those as default as well, but I'm going to open subpage and add lead in and lead out. So let's activate entry exit. Entry curve, this is your lead in, and I want my lead in to be used always, so for every depth. And I'm going to use percentage of the tool diameter, and I want to have both length and thickness on 75%. And those settings I'm going to copy to the exit curve, and automatically it will take exit and always use. And I want to slightly overlap, let's say 1 mil, to overlap the contour. Okay, I'm going to set quickly my safety zone, and I want my safety zone to be on 5 axes, define shape, and select, click on 3D model, and then we will go and select wrap, and that's it. This is what I want, this is what I need. Okay, and the last settings we're going to make is on roughen page. Okay, so I'm going to activate depth cuts, and I'm going to set 3 cuts, and let's say 4 mil each, and the cuts are being calculated from the depth of the, one moment, should be -10. Okay, so the cuts are being calculated from the maximum depth, so from that plane we selected, and each contour, each pass is going to be calculated in depths from the deepest cut, so 3 depths, 4 mil each. Okay, so let's go back to roughen page, and I don't need finish cuts. We do not have a floor, we are cutting deeper than the bottom edge of my cutting faces. So in my case, number of finish cuts is 0. Okay, let's go and check the result. And this is our tool path. Okay. All looks good. Okay, and with my next toolpath, we are going to finish side walls of each cutout. And before we start setting the operation, we need to create some additional geometry. And for that, I created new level, tilt lines, and all my geometry that I'm going to create will end up in this level. So I can later switch it off because I'm going to use it only for this toolpath. So navigate to wireframe, curve one edge, and my tilt lines are going to be those lines. Okay. So all the vertical lines between each face. Okay. So those lines I will use to represent the tool axis. Okay. And also actually I'm going to create the curve on the top edge, and I'm going to use that to drive my tool. So it's gonna be my tool path. Okay, I don't need this one. So this is what I created. Okay, so one more thing that I'm going to do is to break this one line into two pieces, and I'm going to enter my tool in this position here. So let's go to tool paths and select curve from multi-axis gallery, and I'm going to use 6mm flat end mill. Not going to use stock, and the cut pattern I'm going to use a curve type, a 3D curve, and I'm going to select using wireframe the top edge of that cutout. Okay, and I will do the compensation on the computer, but if you want you can do compensation on the control. The compensation direction I want to be left, and I need to use radial offset. Okay, originally the tool will be pointing, the tool axis or the center of the tool will be on the curve that I selected on this curve here, but I want to use the side of the tool to cut those faces, so I need to offset my tool half of this diameter. So I'm using the 6mm. So from the center to the outside is 3mm, half of the diameter. All this I'm going to leave as default, and in the tool axis control, I want my tool axis to be controlled by lines, and we are going to select those lines. So arrow has to point out towards the retraction, or arrow is showing where the holder is of the tool. Okay, so pointing away from the 3D model. So this is where I selected. Okay, and actually for this one I can use 4-axis output format, and my rotary axis is on Z. I'm not gonna use lead lag angle or the side tilt angle. I'm going to leave it as 0, and I'm going to leave this as default. I'm not going to set any limits. Collision control. So at the moment my Z0 or the bottom of the tool is on selected curve. Okay, but I want to go deeper. I want to pass my deepest point on the face I'm trying to finish. So click on the vector depth, right click, and I want to select the distance between 2 points because I'm not sure what depth it is. So this is the thickest part, the deepest part of my pass. So I'm going to select this arc to the center of this arc, and this is my distance. So I'm going to add, of course, let's say 0.5 mil. So this you need to be with minus because you want to go deeper. If you leave it on plus, it will basically be above 17 millimeter. So I want to go deeper. I'm going to leave this as default. Maybe we don't need to retract as high. I'm going to change it to 60. Roughen. I want to activate roughing cuts. Depth cuts are going to be, let's do it in 4 cuts and 5mm each depth. Okay. I don't need any finishing cuts. I'm just finishing the sides. Okay. So all this looks okay. Let's see the toolpath. Oh, actually in linking parameters, when you click on this plus sign, I want to add some entry and exit. So my entry curve, always use for each depth. I'm going to do thickness and length 60% of the tool. And I'm going to copy that down here. And I want my loop or chain to overlap. So we start here, go around and overlap. So we won't end up with cusp or anything like that. Okay. Actually, I can even go 5mm. Okay. So let's see the toolpath. And this is our toolpath. Okay, this looks okay. So what I'm gonna do now, because our curve 5-axis, it doesn't have utility to transform the toolpath, I need to use the external toolpath transform. And this is easy to set. You have 2 methods of doing this. With the first method, you would ghost this toolpath, and in transform, toolpath transform, just select toolpath transform, sorry. You select this one last operation, and what you want to do is rotate it. So rotate it, coordinate, remove comments, and in the rotate tab, if you ghost this toolpath, you do 4 times. If you leave this active, you do 3 times, and start point is 90 degrees. So it's your next one as a start point, and rotate it 3 times. Okay, 90 degrees each. So let's have a look. My first one and my 3 other. So this is our machine simulation. And let's see, this is the previous toolpath, finishing the cross on the top. So this is how machine is tilting the part. Okay. Okay. Let's go to the next toolpath. So this is our toolpath that we just programmed now. First depth, second lead in, and now we clean the rest. Okay. Next one. Okay. Before I start setting up this operation, I want to create some additional geometry. So I want to have a little bit of that face. I don't want to use the whole face for my toolpath, just this unmachined area. I'm going to use this fillet and the internal part of this arm. And I'm going to drive my toolpath through that, actually through this side. So I need to create my surface and the point I'm going to use for my tool axis control. So for that, I created a level. As you know, I like to keep things organized, and I've got my level already prepared here. So I call that surfaces for parallel internal finish arms. So I know what is inside. Okay, so with that active, so I've got a tick in front of that level, I'm going to create quickly few things here. Using the wireframe tab, I'm going to create curve on one edge, and I want this edge, this edge, this edge, and that edge. Okay, so now I'm going to switch off my 3D model. So these are the lines that I created. Okay, so I can go to my top view, and what I want to do is simply extend those, and trim those. Okay, so this is my flat geometry. So what I can do now, I can go to my surfaces, flat boundary, using chaining to select my wireframe geometry, and this is my surface. Okay, so now when I go back and activate my 3D model, level with my 3D model, I've got that surface, that, and these are bits that I'm going to use for my next toolpath. Okay, just to make sure that we'll get the same result, the surface I've created is on the Y plus of the 3D model. So if you look at the WCS, Y arrow is pointing on that surface. It's important you do create the surface in the same place, as we are going to create a point that we will use to control our tool axis. So the point we are going to create is somewhere here. And this is why it's important to have the surface in the same place, because we'll be driving a tool from here. And now to create this point, go to wireframe gallery and select point. And without clicking on anything, just start typing 15, and as soon as you start typing, the box appears here. And I'm going to give you 3 numbers or 3 values. Each represent different axes, X, Y, and Z. And each one of them have to be separated with comma. So 15 was X-axis, now comma, -27 for Y-axis, comma, -12 for Z-axis. Between each value you need to use comma. Okay, so 3 numbers, 15, comma, -27, comma, -12, and then press enter on the keyboard to accept those coordinates. There is another one important thing that I'm sure you all know about it, but I want to indicate or remind you of that every surface that you create in Mastercam has normals, or front and the back. And let's check what our surface looks like, and navigate to Surface tab and select Change. Okay, and you can change the normals also while you're checking it. So when you hover your mouse above that surface or point on that surface, it will show you the arrow pointing away from the surface, and the arrow pointing away is where Mastercam will create your multi-axis toolpath. So if for any reason your arrow is pointing in the wrong direction, just click on the surface and Mastercam will change the orientation of this surface or normals. And you can do that by using this change program. Okay, so when you click on it, Mastercam will flip its normal. It is important for toolpath. So I'm going to leave this orientation and pointing towards our 3D model. So it is like a wrong way. And I want to show you how this affects our toolpath or the toolpath generation. Okay, at this point we are ready to set our next operation. So navigate to multi-axis gallery, select parallel. For this toolpath, I'm going to use 4mm ball nose end mill. No stock. In cut pattern, I want my cuts to be parallel to a curve, and as my curve, I'm going to select bottom edge of that face here. Okay, I want bottom edge of that arm where we created surface, this edge. Okay. And my drive surfaces, I will select, I want to machine this fillet here, and that surface that we just created, those three faces. Okay. And I want to leave area type as full, but avoid cuts at exact edges. And I want to extend my toolpath a little bit, so I'm going to check this box here. Also, my step over is a finishing toolpath, so I want my step over to be maybe 0.5.1. But for this example, so we can see better, I'm going to use 0.25. Advanced options for surface quality. I want my calculation method to be as exact. And in the extend trim, I'm going to use value instead of percentage of the tool. And I want to extend outside the surfaces that are machined 1 mil. Okay, so we start. I want Mastercam to start the toolpath 1 mil area, pass the whole face, and 1 mil outside. Okay, so we will be extending this cut 1 mil both ways, each way. Parameters for surface handling. I'm going to tick that box, extend edge curve, just in case our parallel to curve is not long enough to generate the passes to cover the full width of the drive surfaces. In the tool axis control, I want to select from point, and I'm going to select this point we just created using the coordinates. Collision control. I want Mastercam to retract tool along tool axis in case it hit any drive surfaces, as well as check surfaces that we are going to select now. And I'm going to drag a window to cover everything inside, including this floor here, and these walls are important because when we will start cutting this face to the bottom, the tip of the ball nose would plunge in that surface, okay, in that face. In the linking parameters, I'm going to set my small gaps to be direct, and I'm going to give it a 15 millimeters. Okay, so if the distance is smaller than 15 mil, it will go direct from the point without retraction to the next position. But if the distance is longer than 15 mil, it will retract first to clearance area. The clearance area I'm going to set as cylinder on Z axis, and I want this to be 60 millimeters. No roughing. And utility, I'm going to select this when we come back. I want to first show you this surface normal difference when we set it wrong way. So this is the toolpath when we set this surface to the top, and as you see, it's tried to machine this surface from the top, but because of our collision control to retract the tool, it retracts it to the check surface level. Okay, so now let's quickly change the normals of this surface. So I'm going to go to surfaces, change, and now I'll fix the arrow to point downwards. Okay, so now Mastercam will machine this surface from this side and then all the way down. Okay, hit escape, regen the toolpath, and after fixing the normals of the surface, you can see the toolpath is generated on the correct size of our surfaces and faces. So as you see, the center of the tool is being kept on that point here, okay, that we selected, because the toolpath is driven from the point. Okay, so this point is not changing the position. Now I'm going to quickly go to compare 0.05 my tolerance, and I want to see if we are not cutting in anything here. I'm going to regen. That's correct. So we are now machining this uncut area from the previous toolpath, and as well as we have finished the whole arm here. Now let's quickly change the utility to do 4 arms. So we're going to transform our toolpath around Z-axis 4 times 90 degrees apart, and before we move to the next position, I want my all faces to be machined. So complete toolpath, and then we will translate it to the next position. Okay, regen, and this is the toolpath. All looks good. We start at the top, going all the way down. Okay. So in our next toolpath, I'm going to finish the floor. So what we're going to do now is copy this toolpath, copy, paste, and I want to change only my cut pattern page, my machine geometry. So I'm going to delete all this, and I'm going to select curve. So my pattern from is going to be that. Okay, so the outside of this floor, and my pattern 2, I'm going to do this pocket here. Okay, and my drive is going to be, we have some fill holes from the first operation. Okay, so I'm going to use that, this small hole here, and this small surface here. Okay, and also in my linking, my default lead in, lead out, I'm going to copy that to this. Okay, to the lead in. So my lead in and lead out are the same now. Select OK. In the toolpath, I'm going to regen this morph operation. Okay. Okay, so this is the simulation of 2 last toolpaths, and I want to see if there are any collisions. Let's crop the back. Okay, collisions. But I think we will have when the tool leads in. Oh, yeah, this is it. Okay, so we see when the tool leads in to the first move, it's plunging into the side of the material. Yeah, so as you can see, we are actually plunging here, and there's something also here I need to investigate. I think when the tool, that's from the first tool path. So when the tool retracts, it's leaving the mark, and maybe the radius is too big. Let's see how it looks like. Okay. So let's sort out first this one. So as I mentioned, this is what is causing the trouble. When the tool leads in, it's hitting the surface here. Okay, so that's simple solution. Just go to parameters, and I'm going to, in the cut pattern page, you're going to select start point. Click on this empty box to put a tick in front of it to activate it, and then as a sub page appears here, position start point parameters. Okay, click on that. We're going to select new position, select that, and instead of starting it here, I'm going to move it to start here. Okay, so I selected the middle of that surface, of that edge, sorry, of this surface. Okay, okay, and I want to have a look into this one as well. So what is the retraction? It is here. Okay, so let's have a look. It looks okay from this side, but let's actually see the wireframe. Okay, I want to see this toolpath, and so, oh yeah, we have a problem here as well. So when the tool retracts, it takes too big distance or too big radius, and it is actually plunging. This is our limit, so we should be inside here, these tool paths here. Okay, tool passes, because the tool goes around here and then it retracts, but it plunges into the surface, into the material. So let's have a look into this problem as well. So in default lead in, what I'm going to do, the width, I'm going to change that width because we are taking too much of the distance. So I'm going to halve that, and that should solve my problem. Okay, let's zoom it out. And let's regen the toolpaths. Okay, both toolpaths ready. So let's have a look. So yes, so you can see on the floor now we are starting the toolpath here where we selected the point. So we are no longer in danger of hitting this wall here. Okay, and let's have a look into this one. What happened here? Let's go to wireframe quickly, and this is our retraction now. Let's zoom in. Let's zoom in. Let's see. Oh yeah, we are fine. So as I said, now we are inside the pocket when we retract, so we are not hitting anymore any of our drive surfaces. Okay, so as a confirmation, let's quickly go to verify. Okay, so this is our machine surface, and there is no plunge in the wall anymore, and also we do not have any scratch on this wall anymore, so all looks good. I'm gonna run quickly compare. Okay, as you can see on the stock compare, we do not have any plunges here. Okay, so with our next toolpath, I'm going to cut this deep pocket inside the part, so this whole pocket, including the floor and fillets, in one go. And for that, I want to use parallel toolpath from multi-axis gallery. Okay, and I'm gonna bring default settings from my default file, and I want to use 4mm ball nose end mill, no stock. I want my cuts to be parallel to a curve, and I'm going to select the top edge of this pocket, whole edge around. Okay, drive. I'm going to double click on one of the walls to select whole pocket, okay, including floor and the fillet. I want to avoid cuts at exact edges and want spiral for my cutting method. We could be spiraling from inside, outside, and up the way. Okay, and step over, of course, for the finishing toolpath, because that's finishing toolpath, I would use 0.05 step over, and probably I would tighten up a little bit this tolerance here, but I'm going to leave it as 1 mil because I want to show you something. Okay, some of you might already know about it, but I'll show you something interesting with this toolpath. So perform spiral. I'm going to use a full spiral, and I want to close on the first and last contours. Exact method of step over calculation, and we can smooth the toolpath a little bit. Okay, and I want to use 5-axis output format, and I want my tool axis control to be from point, because we are cutting this internal feature and we have only one way to get to this pocket is from the top through that gap here again. Okay, in collision control, I want to retract tool along the tool axis if my flute, shoulder, or shank will hit drive surfaces or check surfaces. And my check surfaces, I'm going to select the whole top here plus this floor around my pocket. Okay, that's all fine. I'm going to leave default settings on those positions here. In linking, I want to use direct linking for small gaps, and for any large gaps I want to retract to clearance area. So if the gap is greater than 100% of my tool diameter, which is 4 mil, I will retract to clearance area. And my clearance area I'm going to set to plane on the z-axis, and I'm going to use 25 here and 50 millimeters here. Okay, and I would like to use lid in and lid out. For my first entry and last exit, I will use lid in and lid out. And I'm going to set only default lid in and lid out. I want tangential arc, and because we are driving the tool from point, I want my tool axis orientation to be tilted. I'm going to set height. I don't want to lid in on this flat bottom face, leaving a mark, circular mark. And for my height, I want to add a couple of mils to drive this tangential arc not only on XY but also on the Z axis. So we won't leave that circular mark across our passes. And I'm going to use 2 mil as I said and copy all that to here, okay? Nothing in roughing, nothing in utility, all switched off, and my planes are top. And let's have a look into our toolpath. So we had pattern from the top edge, and this is our toolpath. It starts here and go all the way up. But when we cut this area, I go and start going up the way. The tool is being engaged with a lot of material, okay? Maybe it'll be easier to see when we go and see the verify. So this is how it looks like, okay? So we are cutting from inside towards the outside. And this is the moment where we are actually engaged with a lot of material. The tool is actually cutting quite a lot of material, okay? And then we are going up the way, and each pass is quite large amount of material this tool is taking. I want to show you a nice trick that I use sometimes inside this parallel toolpath. So I'm going to copy last toolpath, and I'm going to change only one thing. I'm not sure if you are aware of, but you can select multiple chains in curve to be parallel to. You don't need to select just one chain, okay? So for example, I want this floor to be cutting from inside towards this chain here, okay, leaving a little bit of material on those walls around. And then, because that is finished, Mastercam will try to finish the rest of the material, and I want Mastercam to go towards this chain, okay? So we have 2 chains. So we'll cut from inside towards this, and from the top we'll go towards this chain. And let's have a look at the difference. Okay. So this is how it looks. Floor and the outside walls. And the walls are going from top down. Okay. Okay, the last thing we need to finish now is those cutouts on each arm. Okay. And for this we're going to use parallel again. So let's go and select the parallel, but I want to bring my default settings because everything going to be different. Okay, I will use 3mm ball, no stock, cut pattern. I'm going to select outer edge. Okay, so this is my pattern 2. Okay. My drives is going to be hold this pocket. Double click on one of the faces and we'll select the whole pocket for you. And of course my step over would be 0.05, but I'm going to use 0.25 just to show you the pattern. Okay, I'm going to use one way cutting method, no stock, and because I want to cut away from the curve that I selected, I need to flip step over. So without flip step over, it will go towards the parallel 2, and if you want to use parallel from this curve, you flip step over. I hope it's clear. Okay, I'm going to use exact method calculation. That's okay. and here. I'm going to use output as 5 axis with tool axis control surface with tilt. But what I want to do this time, I want to use the common direction option here. Okay. What it does, Mastercam will find one common setting for your A and C axis, or B and C if you use a mill-turn, and it will finish all this pocket from one locked position of your C and A, or C and B. Okay. This also many times will improve your surface quality, surface finish, because you don't have all the axes changing constant position. Okay, so that's fine. And the collision control, I'm going to retract the tool along surface normal, and I want the report on collisions. Okay, as a check surface, I'm going to select that. In linking, I'm going to use, that's fine. We won't have any retractions anyway. It will be one in, one out. And my clearance type is going to be automatic. The last thing I want to set is transform. We have 4 pockets 90 degrees apart around the Z axis. And my work coordinate system, tool plane and construction planes are top. We can turn on coolant. And let's see the toolpath. Okay, so we've got our report, no collision found. Good, and this is the toolpath. Okay, looks nice. So, as you can see, everything is being cut from one orientation. We move here, and all is being cut from one orientation again. This is all for today, my friends, and thank you for watching this tutorial. Don't forget to download the 3D model and tool database, and hope to see you in a few weeks. Take care.